Greetings, fellow grade 11s. It's Mr. Lajaro here, and welcome to Back to Basics. Look, what we are looking at basically today, we are going to be examining our natures of roots, right? Now, in order for us really to understand our nature of roots, we need to start here. Now, for an example, how can we understand the word nature of root itself, right? Now, it is important to take note that the word nature of roots basically it refers to what? It refers to character of numbers, right? So the nature basically it refers to character of numbers, right? So basically that. And now your root in this context, your root here it's going to be representing what? The root of any of the equation in a solution, right? Or rather, it represents your what? It represents your solution of your equation. Root represents your what? It represents your solution of your what? Of your equation, right? I know probably that you are probably thinking in terms of, what is this thing? Now, for an example, it is important to understand that now when we discuss about the nature of roots, we are describing the type of numbers that the root can be. Again, so we are saying we are describing the number in terms of what is the significance of this number in this particular equation, right? Now, the root of any equation. Now, the root of any equation is going to be what? It can be found within your root of ax squared plus your bx plus your c. Out again, which is equals to your zero, of course. Out again. And now, in any of the equation where you are having your ax squared plus bx plus c, here, in order for you to determine your natures of root or to solve anything that have to do with natures of roots, right? Now, you are going to be what? It can be found. You are going to be using your formula, which is going to be x is equals to negative b plus minus your b squared subtract your 4ac over what? Over your 2a. Are we together? So basically, that's going to be that. And why are we saying that? Now, for an example, it is important to take note of this. Now, remember, we are saying under nature of root, we are going to be describing you what? We are going to be describing this thing which we call our discriminant, right? Now, so we are saying your nature of root can be defined by what we call a discriminant. A discriminant, right? It's discriminant. Okay, and discriminant basically, it is what? It is this, triangular like type of thing, or others they call this your what? Your delta, right? It is also called your delta. Right now, let's understand this discriminant or this delta thing. Now, we are saying your delta is categorized what? Your delta is always going to be given by this formula b squared subtract your what? Subtract your 4ac. Right now, we are saying now your discriminant is always going to be defined by what? By b squared subtract 4ac. But now, of course, under the nature of roots, we are going to be examining the three categories of roots, right? We are going to be describing, or rather, we are going to be learning about the three categories of roots. Once again, now for an example, let's start here. Now let's just make up our space here so that we can be in a position to describe these three natures of roots that we are going to be referring to here. Now, we are saying firstly, now, remember we said we are having this discriminant. A discriminant which is equals to b squared subtract your 4ac. And we are saying this, it can be described under three categories, right? Now, we are having the roots where we are saying your roots are non-real, right? We have this category where we're saying the roots are non-real. Now, what is it that we mean when we are having the roots that are non-real? For an example, if I can say, for an example, I give you your square root of negative 17. Is there anything that you can find this? You'll realize that now the square root of negative 17 does not exist. Out again. Or for an example, now, if I can give you your delta, which is equals to negative 17. Now, this is one of the typical examples of the roots that are what? Of the roots that are going to be non-real. Oh, it's okay. And now, what is it that we know about non-real roots? We are saying under non-real roots, it's when basically you are having your b squared subtract your 4ac being less than 0. Out again, it's basically when you are using the formula b squared subtract 4ac, you are getting a solution that is less than 0. Out again, but we are going to be dealing with more and more of the exercises of those things, right? Now, so we are saying graphically, now if let's say you had to plot your graph, right? Now a graph that is having non-real, basically it is not going to be having your x-intercept, right? Your graph that is non-real, basically it's not going to be having your intercept. Out again, so basically that is going to be your graph that is going to be non-real. Now let's say now we look at another different category, right? Now we are saying the other category that you can have here, you can have the roots, where we are saying the roots now here are real, right? Now, and when you're having your roots that are real, what is it that you're going to do? Now, for an example, we are saying basically here it's when you're having your b squared subtract 4ac being equals to 0. Once again, now that's going to be your real root when your discriminant is equals to 0, right? So we are saying this is when your discriminant is equals to 0. Remember, your discriminant is represented by b squared subtract 4ac. Once again, so basically that is going to be that. Now and then we are saying this can be known as real, or it is going to be known as, sometimes they can use where you, what they say, find out where your roots are equal. Now when your roots are equal, they still mean real, or sometimes they can still use the word what, rational, right? Now the word real, rational, or equal still just means where your delta is equals to 0. Once again, now for an example, if you can look at your square root of 0, you're going to have what? You're going to realize that this is going to give you your real your real roots. Or rather, when you are having your discriminant, which is given by what? When you are having your solution, basically when you are substituting your b squared subtract your 4 and your ac, you are finding your answer as 0. Then you'll know that your discriminant, or rather you'll know that your discriminant is going to be real. Once again, now under real roots, now in terms of our function analogy, right? Now we are saying here, it's when basically you are having your what? When you are having your turning point of your graph, it's when you're having your turning point of your graph as an intercept, right? It's when you're having your turning point of your graph as a what? As your x-intercept. So basically that's when you're having real roots. So basically it's when you're having your x-intercept altogether, or when you're having your turning point as a what? As your intercept altogether. So basically that is going to be that. And now we are also saying, now after real roots, you are going to be having this, which is called what? Now you are going to have your roots that are what? You are going to have also your roots that are real, but now they are going to be unequal, right? Now we are saying you can have your what? Where now you are having your roots. Let's get another color so that you can differentiate this, right? Now, let's say we are having, now remember you can have now the roots that are real. Now, but now under real roots, they are saying now you are having two unequal roots, right? Let's say we are saying you're having two unequal roots, right? Unequal roots. So basically, what does two unequal roots basically means? Here we are saying this is going to be again where your b squared subtract what? This is going to be where your b squared subtract your 4ac is greater than 0 now, right? Now it's going to be when you're having your b squared subtract 4ac as you're greater than 0 now, right? Now they can say this is unequal roots. Others they can say what? Others they can say also it's going to be your what? Your rational roots, right? Others can say this is going to be your rational roots. And now, and then under rational roots, you can have two categories, right? Or under these real roots, you can have the roots of what? Of your perfect square. Now, perfect square is basically when you are finding the square root of your square number. Once again, when you are finding your square root of your square number, for an example, when you are finding your square root of 25, or when you are finding your delta being equals to 25. Now, this is going to be what? This is going to be your perfect squares, right? This is going to be your perfect square. However, now when let's say you are finding a value of your roots, but now let's say you are finding your answer as your square root 3. Now we are going to say this is going to what? Oh, let's say you are finding your delta being equals to what? Being equals to 3. Now, this number that you are finding here is not your what? Is going to be not your perfect square, right? But now, as long as it is still greater than 0, or whatever that you found, as long as it's still greater than 0, it still qualifies to be what? It still qualifies to be your two unequal roots. Now, graphically, graphically now we are saying now, let's say now this is going to be your Cartesian plane. Graphically, we are saying now you are having two different values of x here. It's when you are having, let's say, your first x value here, and when you are having your second x value here. Okay, so basically that is going to be when you are having what? When you are having your two unequal roots, or rather when your roots are what? When your roots are going to be real and unequal. Okay, so basically now those are going to be the things that you are going to be learning about. I know basically that you are asking yourself in terms of how do I then apply this in the normal equation, right? Now, let me just give it to you now. Let's say now we apply all these things that you are learning about now in terms of your roots being real and non-real, equal or unequal, all these types of things, right? Now, let's just make up our space here. Now, let's say in this case, let's say you are given this question, all right? Let's say firstly, the first question is determine the nature of roots, determine the nature of roots, the nature of roots, right, of roots. If let's say now we are given that, let's say they give you an ordinary equation. Let's say you are given your 2x squared subtract your 5x plus your 9 is equals to 0. Now they say determine your nature of roots, right? And now we are saying now, we can see that basically this nature of roots will only depend on what? On your delta formula, right? Now, which means the first thing that you're going to do now here is you're going to say now, what is going to be your delta? You're going to say your delta, remember delta is given by b squared subtract 4ac. Now, we just want to find out in terms of the three categories of roots that we've previously categorized. Now, where is this particular equation going to be belonging to? Now, and then we are saying, remember now, whenever we are using your PAC, right? Now, what is this? We are saying here, remember this one, under your quadratic equation, this represents your A, this represents your B, and this represents your C. Now, therefore, what is going to be your delta? You're going to say your delta is going to be given, what is your B? Your P is given by your -5 squared subtract 4, and then your A is given by +2, and then your what? Your C is given by 9, right? And when you work out on this is going to be 25, and then this is going to be that. Let's see the answer that you're going to get here. Let's see now. We are saying this is going to be same as your 25 subtract your what? Subtract your 8 multiply by 9 altogether. And now the answer that you are finding here, your discriminant that you are finding here, it's -47. Now, and you remember that under the three categories that we described, now we said you can firstly have a value that can be let's start here. We said firstly you can have a value that have a discriminant being less than 0, right? Your discriminant being less than 0. You can have your value where your discriminant being equals to 0. You can have the value where your discriminant is greater than 0. Remember this one, we said this one is non-real, right? We said this one is non-real. We said this one is going to be real, right? But it's only one equal root, right? One equal root. This one is also real, but now you can have what? You can have two unequal, right? Unequal roots. Altogether. So basically, that's what we've discussed. Now, if you can check the value, which means here your delta is what? Basically, your delta here is negative, right? And here your delta is equals to 0, and your delta here is what is positive, which means it's having a positive number, right? Now that you have that, the negative 47 is going to belong to what root? Now the roots of this is going to what? The root of this is going to be what? It's going to be non-real, right? The roots of these are going to be non-real. Why? It's because it falls under the category of what? Under the category of negative, right? So this is going to be non-real, right? Altogether. Why are we saying non-real? Because your delta here is what? Your delta here is less than 0. Altogether. Now let me say while we are still on that, let me say I find you another equation. Let's say now you are given that you're having x squared, let's say plus 1 is equals to 2x. We are still finding out our nature of roots. What is it that you're going to do here? Obviously, you're going to start by writing this in your quadratic equation. So this is going to be x squared subtract 2x plus 1 is equals to 0. And the next thing that you're going to do, you're going to find out what is going to be your discriminant. Now your discriminant is given by what? It's given by b squared subtract your 4ac. And now from here, what is going to be that? This, your discriminant basically is going to be given by what? What is your p? Remember we said here, these represent your a here. Your a is same as 1, your b is same as your negative 2, and your c is same as your 1 here, right? So which means this is going to be same as negative 2 squared subtract 4. What is your a? Your a is 1, and your c is given by what? Your c is also given by 1. So now from there, which means your discriminant is going to be given by what? Now, if you can calculate this, you'll see that this is same as 4, right? This is going to be same as 4 subtract what? This is going to be 4 subtract 4, because 4 multiplied by 1 plus by 1 is same as 4, which means your discriminant here is equals to 0. And whenever you are finding your discriminant as equals to 0, amongst the three categories, it's going to be belonging to which one? It's going to be belonging to the category of what? The category of real. Now, this is going to be belonging to the category of real. Altogether. And now remember, real, we said also real can be what? Your real can be also your rational. Altogether. We said this is also can be your what? Your rational. And also now your what? Because now your discriminant here was equals to 0. So that's why we are saying this one belongs to that particular group. Altogether. Now let's say let's say from there, what else now can we do now from here? Let's say we try to find out something else. Let's say now give you another last example here. And now from this last example, let's see that what we are having. Now let's say in this last example that we are having here, I give you that you are having x. This one. Let's say now this is your example 3. Let's say now here I give you that you are having, let's say, x squared, let's say subtract 5x, then this is going to be subtract 6 is equals to 0. Now, how can we go about solving this? Now, you are going to start by finding what you are going to say. Remember here, you are going to use your discriminant, which is equal to b squared subtract your 4ac. Okay. And now, what is it that you're going to have now here? Let's find out. This is going to be same as what? This is going to be same as your value here is going to be what? Your discriminant is going to be same as your 5 is same as negative 5 squared subtract 4. And then your a is given by 1, and your c is given by what? Is given by 6. Altogether. And now, rather this is negative 6 because it have a negative sign there. So this is negative 6. So, and then this is going to be same as what? Your discriminant here is going to be same as 25 subtract. What is it? What else now are you going to have? When you say now here your 4 multiplied by what? Your 4 multiplied by 1 multiplied by negative 6. What else now are you going to have? Now the answer that you're going to have here, it's going to be your 24. Altogether, it's going to be basically your 24. And now if this is your 24, which means this is going to be same as what? plus 24. Now, what is going to be 25 plus 24? Let's see, when you say now 25 plus your 24, you realize that your answer that you're going to find here is going to be 49, right? Your answer that is going to be 49. And now, how can you categorize this as part of the three categories, right? Now, this one can be categorized as what? As real. Why are we saying this real? Firstly, if you can look at your delta is greater than 0, right? So now this is going to be real. But now, as this is real, it's going to be now, firstly, it's going to be part of what? Now, this is going to be part of your perfect squares, right? Perfect square. Now, why are you saying your perfect square? Because if you can say your 49, when you say find out what is going to be the square root of 49, you'll find out that this is going to be 7. That's okay. So, which means this one is going to have 2 equal roots. This one is going to have 2 equal roots. Altogether, this is going to have 2 equal roots. So basically now, that's how you can categorize this one. Let's say now from here, I just get one last example, right? I want to write this last example here so that you can still be in a position to compare all these examples of ours and be in a position to point out which one is which one, right? Now, let's say last one, let's say now I give you that you're having x squared plus 3x, and then now minus 10 is equals to 0. Now, remember, we said to start by finding the discriminant. The discriminant is given by what? B squared subtract your 4ac. Okay. And now, what else are we then going to do now from here? We are going to say from here, now what is going to be your P? Your P is going to be same as 3 squared subtract your 4. Your A is 1 and your C is negative 10. And now this is same as what? Your 9. This is going to be 9 plus what? 9 plus 4. Or rather 9 plus 40. And 9 plus 40, again, you're getting your 49. And what is going to be your delta of 49? Delta 49, can you see that your delta is greater than 0? And if this is going to be greater than 0, which means your root is going to what? Your root is going to be real. Right? And now if your root is going to be real, we are saying also your root is going to be rational. And we are also saying now this is going to be what? You are going to have a complete square, or this is going to be what? You are going to have your perfect square, or rather your complete square. Let's say we use the word complete square, right? Or which is same as perfect square. Why are we saying complete square? Because when you are finding the square root here, you are still going to have the same answer, right? You are going to have the answer for your square root. Again. So basically, this is how you are going to, firstly understand these fundamental basics, or rather basic questions on what? On roots. Hopefully this makes sense to you now. And thank you very much.